Similar to Earth's energy balance, we can also construct a carbon balance. This helps us to keep track of humans' interference of the carbon cycle. This slide shows the carbon budget or carbon balance for Earth for the years 2003 to 2012. In this image, the carbon balance is done in gigatons per carbon. Typically, we measure carbon dioxide or carbon when we talk about the carbon cycle. A gigaton is 1 billion tons. So usually we measure changes in carbon using gigatons of carbon or gigatons of carbon dioxide. 1 gigaton of carbon equals 3.664 gigatons of carbon dioxide. So we can easily convert back and forth. Keep these units in mind as you look at various figures. In this carbon budget, carbon is measured in gigatons of carbon per year. From 2003 to 2012, humans added 8.6 gigatons of carbon per year by burning fossil fuels and 0.8 gigatons of carbon per year by deforestation, for a total of 9.4 gigatons of carbon per year. The oceans took up 2.6 gigatons of that carbon, while the terrestrial system also took up 2.6 gigatons of carbon per year. We've measured that 4.3 gigatons of carbon per year remained in the atmosphere. This is a more recent estimate of the carbon budget. It's from 2008 to 2017. This one is done in gigatons of carbon dioxide per year. I've added in black the gigatons of carbon per year to make it easy to compare to the 2003 to 2012 values. In this plot, big arrows are related to human alterations of the carbon cycle, while small arrows show natural processes moving carbon between the spheres. The circles are carbon stores. Take a look at these numbers and compare them to the 2003 to 2012 carbon budget. Are they different? This plot shows a summary of the information on the following figure. On the left is carbon added to the atmosphere by human activities. Here, 9.4 gigatons of carbon per year comes from burning of fossil fuels. 1.4 gigatons of carbon per year comes from deforestation. Add those numbers together and you get a total of 10.8 gigatons of carbon per year. This carbon has to go somewhere, and we can see whether the carbon we produce adds up to where we can measure carbon in sinks. We know that about 4.7 gigatons of carbon per year is added to the atmosphere. 3.2 gigatons of carbon is taken up by photosynthesis in the terrestrial system, and 2.4 gigatons of carbon per year is taken up by oceans. If we add these three numbers together, we get 10.5. That's not equal. There's a difference of 0.3 gigatons of carbon per year, or about 2.0 gigatons of carbon dioxide per year. We don't know where that carbon dioxide or carbon is ending up. This slide also shows emissions in sinks. What you see are emissions on the upper part of the plot and sinks on the bottom part of the plot. Emissions are released into the atmosphere from land use change and fossil fuel burning. Sinks are where that carbon is taken up, some by the oceans, some by the terrestrial system, and the rest stays in the atmosphere. You'll notice a faint gray line. This is where we have an imbalance, where our emissions don't equal our sinks. Our carbon budget or our carbon balance is not imbalanced, or is not balanced rather. The difference between this, or the gap that we see, really reflects one of two things. One, we have some imperfect data. Or two, we don't completely understand the carbon cycle.